Good morning, Taimina Khan is here in TKMaths S1. In today's video, we will solve a question on binomial theorem. It is a part of the syllabus of O-level additional mathematics, and I have taken this question from November 11, variant 1-1, question 7. According to syllabus, you need to know how to how to apply the expansion of the binomial theorem, number one thing, and secondly, about the general term. So we have a part of the question which consider general term, because general term question asked in multiple ways. So if you go to my website address and go under the heading of challenging question, you will see I have listed down all the topics here. So when you will click on binomial theorem, you will get the videos I have uploaded so far or which I keep uploading. So it is still in the developing stage, so there are few questions, but very soon there will be many questions on it, all types, different types of challenging question. So to solve binomial questions on binomial theorem, you need to recall these formulae, right? Now this is n factorial. In general form, it is written like this: n minus 1, n minus 2, and so on. So remember one thing, when it is, for example, n factorial and you need to stop somewhere in between because of some reason, so you can stop right then and there, right? It's just like you have 5 factorial, for example, you can write till 1, 5 into 4 into 3 into 2 into 1, or if you want, you can stop here, for example here, and you can write 5 into 4 factorial. So you should have this knowledge. Secondly, what is the meaning of NCR, which is written sometimes like this, rather in the past paper, when you will get the question paper, on the first page the formulas are given, so it will be written like this. So NCR, when you expand, is becoming n factorial n minus r factorial into r factorial. Remember this thing. Now this is, I have just written NC1 actually means n. You can check in the calculator. You are allowed to use calculator. For example, 6C1 is equals to 6, just for the quick calculation. Then this is the general formula for the binomial expansion. You can see here. It will be given to you in the exam, so you don't need to remember or learn it by heart. Now the special case which is derived from here, if a is 1, right, all the a's will be replaced by 1 and the formula will take this shape. So these are the things you should be able to recall. Now let's see the application. For example, if I have taken this question just to develop the understanding, so how do you expand it? You see, in place of b I'm writing x, and in place of n I'm writing 5, and this is how you expand it. So now let's see the question. The coefficient of x square in this expansion is given to you 3 upon 5. And you have to expand this. You have to pick up the term of x square and you have to put it equals to 3 upon 5, right? So why did I use only this term? Why I did not write all the term up till x square, like using this formula, till here all the term? The reason is, when you have the first term 1, you know this term will have x square when you will have nc2 here, and this we have gotten from there, from the expansion, and I want x square. So that's why I have written directly this particular term nc2, because n is unknown here. So I have written nc2 x upon 5 square. So I have picked up this term. I will put up video here which have x here and x here also, maybe in the numerator and the denominator. So those type of questions are tricky when you have x present in both the terms, either in numerator or denominator. So those tricky questions I will put up in the video. You will see it on the link. Anyway, so right now we have written down here the term which have x square, and we are expanding nc2 with this formula which I have shown you up there. You need to recall that. So after writing it, now because it is given that the coefficient of x square is 3 upon 5, so now I will pick up all the term except x square. So I will leave x square and the rest of the terms I'm writing here. You can see n factorial can be written as n minus 1, n minus 2 factorial. Why did I stop at n minus 2? Because there was n minus 2 factorial in the denominator. And I put this equals to 3 upon 5, you can see in green color, because this was given to us in the question. After that, I will simply do cross multiplication, get a quadratic equation, factorize it. and solve it. N is equals to 6. Why I did not write the other value of n, which is minus 5? Because n is positive, right? It is given here, positive integer. Even if it is not given in your syllabus, you have only the terms which have n positive. In A level, you will see other values, negative fraction and all. Second part of the question, which students usually find tricky, because it is saying find the value of n, find the independent term of x in this expansion, and we will use this value of n. It is given here. Now, term independent or term constant, any word can be used. It means x power 0 or the term which does not have x, right? Now, this expansion we have done in part 1, right? That was part 1, but we did not do the whole expansion, we can show here. And this reminds us the algebraic identity a minus b whole square, which is a square minus 2ab plus b square. Students usually start applying binomial here also because they are in a mode of binomial theorem. So it's not wrong, but it simply wastes time. So rather, if you just apply algebraic identity, it will make it faster. Okay, so I have applied here the expansion using the formula, and here I have applied the algebraic identity. You can see the same formula, a square minus 2ab plus b square. Sorry, this should be plus here, right? Okay, so after this, I am simplifying it. 6c1, because it's everything is a number, I can use calculator. So I've simply done the expansion here, simplification here. And now it is saying the term independent of x. Now, if you multiply all of them, you will get 9 terms, which will waste your time. So you do mental calculation, which terms we will multiply to get terms without x. So number 1 is this one, because x has power 1 here and x has power 1 here. It is in the numerator, it is in the denominator. It will cancel out. Secondly, if you multiply this term with this term, then again x square will cancel out. If you will multiply the other terms, you will get x in them, right? So independent of x mean it should not have x, it should cancel out. So I will only multiply these terms. Or sorry, I forgot this one. 1 times 4, because there is no x, so it will be. So 1 times 4, and then this term I have told you, which is here, and then this term, which is here. I have simplified basically 5 3s are 15, 5 5s are 25. This is how. And then you simply do the calculation and you get the value minus 5. Now, the mistake here is sometimes students think they have to write or identify the term, right? Here you have to, when they say find the independent term of x, you have to tell what it will be. Actually, not third term, fourth term, fifth term. You have to identify the term here. So thank you very much for watching this video. Please press like and subscribe button and share it with your friends to encourage me. Thank you.